In this video, we'll look at some of the ways in which a limit can fail to exist. The first is perhaps the easiest. The left-hand limit and the right-hand limit fail to be equal to one another, and so the two-sided limit, which is the full limit, can't exist. As an example, consider the function f of x equals the absolute value of x over x. The domain of this function consists of all of those numbers except x equals 0, and this point, 0, is the one which we'd like to investigate the limit for. It's quite common that these interesting points, where the function isn't defined, are the ones where we'll investigate the limit for, partially because these are the ones where the limit is actually interesting to compute, as we'll explain in a later video. To investigate the two-sided limit, we'll investigate the left-hand limit and the right-hand limit separately. The reason we'll investigate the right-hand limit and left-hand limit separately is because f involves the absolute value function, and so f admits the piecewise description whereby it's defined to be one thing for positive x and another thing for negative x. In particular, for positive x, f of x is equal to x over x, and for negative x, f of x is equal to minus x over x. In other words, f is the piecewise function which is equal to 1 for positive x and minus 1 for negative x. The graph of f then comes in two pieces, each of them constant functions, one being placed to the right of 0 and one to the left. Remember also that x equals 0 is not in the domain of f, so we've indicated this by placing two holes in the graph. Now, from this picture, it's clear that as x approaches 0 from the right, that is, from the positive side of the y-axis, the function tends to the value 1. However, as x approaches 0 from the left, that is, from the negative side of the y-axis, the function tends to the value of minus 1. What all of this means is that the right-hand limit is 1, whereas the left-hand limit is minus 1. Because these two values of 1 and minus 1 are not equal, the full limit does not exist. One shorthand way of writing this is using the capital letters DNE for does not exist. Some limits fail to exist for more complicated reasons. For example, consider the function g of x equals cosine of 1 over x. This function is defined for all real x except for x equals 0, which is the point where we'd like to investigate the limit for. In particular, let's investigate the limit of the function as x goes to 0 from the right. We've seen that one way of trying to compute limits is to perform some algebraic manipulation that makes the limit more obvious, but it's not clear whether there's any type of algebraic manipulation that does so in this case. Instead, let's try to plot a table of values for x very small. For example, let's take x to be 0.001, 0.0001, and 0.00001. The corresponding values for the function are listed in the table. As we see, it seems like perhaps the function is tending to the value of minus 1, because the values are becoming very close to this number. However, we shouldn't be so quick to come to such a conclusion. In particular, if we plot the next value for x with 5 zeros followed by a 1, then we get a value that is very far from minus 1, which suggests that the limit isn't equal to minus 1 after all. Indeed, if we were to try to graph this function, we'd see more clearly that the limit can't exist. In particular, whenever x is the reciprocal of an odd multiple of pi, then the corresponding value of the function at that point is minus 1, because cosine of an odd multiple of pi is minus 1. This means that the function is equal to minus 1 for the points x equals 1 over pi, x equals 1 over 3 pi, x equals 1 over 5 pi, x equals 1 over 7 pi, etc. On the other hand, whenever x is the reciprocal of an even multiple of pi, then the corresponding value of the function at that point is 1. This means that the function is equal to 1 for the points x equals 1 over 2 pi, x equals 1 over 4 pi, x equals 1 over 6 pi, x equals 1 over 8 pi, etc. And based on the oscillatory behavior of cosine, we know how the full graph should look then. This curve, which oscillates an infinite number of times before it approaches 0, cannot tend to a single value in the limit. It follows that the right-hand limit does not exist.